Hi, I'm Austin, an application engineer here at United Electronic Industries. Today I'll be showing you how to use one of our strain gauge boards using a LabVIEW application. Strain gauges are sensors used to measure stresses in an object or material. These stresses cause deformations, which we call strain. There are many applications, such as determining expansion of a hot turbine blade, ensuring safe rail conditions by monitoring forces acting on the rails, or even measuring the torque of an automobile engine. The strain gauge is essentially a resistor that changes value due to an applied mechanical strain. The resistance change will depend on the strain applied and the gauge factor of the sensor. Since the change in resistance is typically a very small value, a Wheatstone bridge is used to measure it accurately. This is an example of a quarter bridge strain gauge in a Wheatstone bridge. When the bridge is balanced, the voltmeter measures 0 volts. When the strain gauge resistance changes, the bridge is no longer balanced and a small voltage will appear across the DVM. Measuring the voltage and knowing the gauge factor of the strain gauge, we can calculate the strain on the gauge. There are 3 bridge types of strain gauges: full bridge, half bridge, and quarter bridge. As you can see, the full bridge needs only an excitation voltage, while the half bridge and quarter bridge need resistors to complete the Wheatstone bridge. UEI's AI-224 I/O board was specifically made to handle all 3 types of bridges. On board, there is a programmable excitation voltage, as well as completion resistors to make a full bridge when necessary. One of the unique features of this I/O board is the auto null capability. A strain gauge is hardly ever reading 0 strain at the beginning of a test. The auto null can null out this offset to give a near 0 strain starting point. To simulate various strains, you can use the shunt calibration technique. Applying a resistor in parallel to one of the legs of the strain gauge simulates a tensile or compressive force on the gauge. This ensures that your system can read the various strains that will occur. Now we're going to go into our LabVIEW application to see the AI-224 in action. Here is the front page of our LabVIEW VI. At the top, we see the typical setup for communication with one of our boards, with a resource string, the max and min range, and the refresh rate. Below is the section specific for strain gauges. I've set my excitation voltage to 8 volts DC for a quarter bridge sensor. I've also enabled the offset nulling to automatically calculate the nulling value needed to start at nearly 0 strain. The bridge completion value sets the D to A converter that will simulate the other half of the bridge. I have also set this to auto-calculate. Now I'll run the VI. As you can see, the output starts at 0 due to the offset nulling. And when I apply a strain to the strain gauge, the output changes. From this voltage measurement, and using the gauge factor, we can calculate the strain applied. This LabVIEW example is available on our website. Also, you can learn more about using strain gauges in a white paper called Everything You Ever Wanted to Know About Data Acquisition. You can find the link to it in the description below. And finally, if you have any questions or need help with your application, feel free to contact us by phone, email, or online.